Difference of squares is a special factoring technique used when presented with a binomial where each term is a perfect square and it's a difference. So there's a subtraction between them. So in this case, we know it's a difference of squares because each of the two terms can be written as something squared. So 9x squared can be written as 3x squared, and 25 is 5 squared. So that means it fits the condition to be a difference of squares factoring, or we can do the difference of squares factoring on this expression. And it's actually very simple. What you do is you turn it into a binomial, two binomials multiplied, just like when we factored trinomials. And the first term of each is the square root of the first term. And the second term of the two binomials is the square root of the second term of the original. And then the signs are one is positive and one is negative. And it doesn't matter which comes first. You can put the negative first and the positive second. But that is how it works. So again, you take the square root of the first term. That's the first term of the two binomials. You take the square root of the second term, and that becomes the second term of the two binomials. And then you put a positive and negative in between the two terms inside of your binomial. They're actually called conjugates when the first terms and the second terms are the same and the signs are different. All right, so let's look at another example of that. So looking at these two terms, you have to really recognize and be aware that this could be a difference of squares possibility. So when you look at this, you see, okay, this is x squared, and 81 is 9 squared, and it is a difference. It's a minus. So we can fit it into our two binomials. It'd be x, 9, 9, and just put a plus in front of one, minus in front of the next, and you are finished. All right, let's try one more. Okay, same thing. It doesn't matter that the x squared is on the right side. It doesn't matter at all. As long as it's a difference, and each of these are a perfect square. So what times what is 36? So 6. And what times what is 4x squared? 2x. So when you open up your two binomials, 6 goes first, and then you have 2x plus minus. Actually, if you look at this, each of these has a GCF that we could have taken out to begin with, but since we're just looking at difference of squares, that's all we'll look at right here. So this would be the factored form of that. Okay, why don't you try this one? So pause it. And here's the answer.